Hey guys, this is Fred from Pretty Fly Games, and today we're going to look into how to add models from Townscaper into Unity. Townscaper is this cool little tool that Oskar Stålberg has created, where you create towns or cities in a very easy way. You just click on anywhere and it creates a sort of procedurally generated town, but you can control how it should look like, and well, it's a lot of fun, and you can create a lot of complicated structures and towns with this little tool. There is a nifty export feature that exports this into an object file. The problem is when you open it in Unity, it doesn't look anywhere close to this. So today we're going to look at how you can fix that. Importing a model from Townscaper into Unity will make it look like this. It looks kind of broken and nowhere near as it should look when you're viewing it in Townscaper. So the reason for this is that Townscaper is using different kind of methods to render the model, and it's not using regular UVs. So what we will do is we will arrive with a shader that makes it look like this, which is not perfect. It has some issues, and but it's a lot closer to the real rendering in Townscaper compared to what you get as default in Unity. So to understand how we reach this point, we need to also understand what is driving this change, or how the model is constructed and what methods are used. And the first part, I need to say that I'm no shader wizard, and a lot of this how it's been done and has been reverse engineered by a lot of other people. I've just studied it and looked at what they've done, and then I've reproduced that in Unity and added some of my own methods as well. So the good part is that Oskar, who created this, has shared a lot of information on Twitter, so you can follow him there and read exactly what methods he has done to create his very special style. So the first part in this is that you need to understand UVs. Now a UV map is just a regular image like this. It's a flat image which is then projected onto triangles that forms a mesh. So these coordinates tells the computer how to map this into this cube. So the coordinates usually go from 0 to 1.1. So they are staying in this boundary. Now the first problem or challenge is that Townscaper's UVs are not regular UVs. They contain a lot more information than your regular UVs, and that is why they are not working in Unity, Blender, or any other program that you will use, and if you just try to render them out of the box. So if you look at the UVs, it can look something like this. You have a U vector, which tells what sort of part of the X coordinate system in an image should be used, and a V. And normally, as I said before, these usually go between 0 and 1, and as you can see, this has a large value and then followed by some other value. So what does this mean? Well, to get the results, we need to understand how Townscaper is mixing the various textures it has to achieve the end result. And if you install Townscaper on your computer and you go to your user folder, app data, local low, Oskar Stålberg, Townscaper and textures, you will find a couple of files. So the first file is towncolor.png, and the town color describes a bit how well, as you can see, it has the door and the window textures, but it also has a lot of other funky things that looks like bricks and tiles, and that is exactly what it is. These are the parts that make out sort of the detailed texture in Townscaper. Then we have another texture called town material. That is the same size as town color, and it contains various parts that is used to interpret what type of sort of material is this, what type of material is it in the object, and we'll come into it a little bit later. Then we have the last part, which is a town palette, That is just a texture that contains 16 different colors or 17 different colors, and it goes from red until gray. So if we mix all of these together in a special sort of mixture, then we get this result. So how do we do this? Well, the first part is to understand the townpalette.png texture. The first part of our UI coordinates, as we said, could be a large number, like 9, 4, or whatever. But in this example, we'll use the 9. This is actually the key that tells us what color should be used in the color in this palette index, sort of. So if we render only using the town palette and with this special shader, then we get this result. So how it works is that we take the 9, which corresponds to color number 9 inside our nice palette texture, and that is applied then to the side of the house. And the same for all the other colors. So our UV9 corresponds to a number here, which is also the color. Now, as you can see, the roofs are all red, and that is because they are coming from somewhere else. They're not using the regular palette. We'll come into that as well when explaining the materials, which is next. So if we render our image again, and we are only using the town material in this case, we can see that it's mapping the different materials out in different colors. So if we look at the UV parts, then we are using the fraction part of the UV, which is describing what material a building has. So this cyan color means that it's a roof. Then we have the blue, which means that it's a regular wall. Then we have some other colors like this in between, and there are additional colors as well that is sort of hard to see here. We have a bit of a pink here. So all of these colors mean different things when we are rendering the final image. Then we have the town color.png texture. So if we render this out with a special texture again, or a special shader, then it looks like this. So this is the complicated part, and it's actually really complicated. This texture is a 128 by 128 texture, and it's not really a regular texture, and it's not really a color that it says here. It's actually tiles. So the technique used in Townscaper is based on tiles, and this texture describes what tiles we should be using for the different parts of our models, basically. So again, we look at the fraction part of the UV, and this tells us what tile it is, but we need to convert it into pixel space instead of regular UVs. So the texture is 128 by 128, so we need to do some fancy math to convert it into that space. Then they are using something called half pixels, or Oscar is describing them as half pixels or half tiles. And what it means means that every even pixel tells us what tiles to use. The odd pixel tells us what gap should be in between the tiles. And this creates the special style in Townscaper, where you get very good sort of straight lines without too much interference, because they are not regular. They are a little bit stretched in a way that is using a special technique for that. So it's very good for creating different type of architectural structures like houses and walls and things like that, because all the different lines that makes up these objects becomes very sort of easy to see, and it looks really good. So how we mix everything is quite complex, and we'll use a different type of shaders, or we'll actually use one shader, but we will use different type of techniques and mathematics to mix it. So, but before we go into Unity, and I'll show you how to do this, then please understand, this is not a one-to-one style of Townscaper. It it contains a lot of bugs and problems, and features are just not correctly implemented in this. So if we look at the windows as an example, they don't look like this in Townscaper. They are going into the building instead of sticking out like this. And the reason why I have it like this is because I haven't figured out yet how exactly to do it the other way. But that's something that hopefully I will find out in the future and figure out. The same goes for the plants and everything else. These are not looking 100% correct, and you can tweak them by yourself and try to get them to look even better. Alright, so with that said, let's look at this project in Unity. So if we take a model and we import it into Unity straight away, it will look something like this. This is just a plain model exported from Townscaper and imported right into Unity. And as you can see, it looks very different. So as I said, all of the features have not been implemented, like the water. It's not implemented in the shader, so let's get rid of that. And I'll just replace it with a flat sort of space that has a single color, and then it's using a standard plane. Then we need to look at the textures. So if you're importing the textures by yourself, then there are a few settings that is super important. So first of all, you need to make sure that you have the alpha source as the input texture, and it's gonna be used the alpha is transparency. So check those. Then you want to disable the generate mip maps. And the reason is we don't want Unity to make smaller sort of textures from our textures, because that will mess up our lookups. So when we're looking things up into the texture, they have a different size and it becomes very complicated very fast. So uncheck that. Then set the filter mode to point and make sure that you don't have any compression at all. So after changing those values, it will look like this. So the second thing is that you need to select your town or the model, and then we'll go into house, and I've provided a few materials. So we have house materials, so let's drag and drop that in there. Then we have our birds materials, so let's hook that up, and our fencing, so we have fence, and then we have our plants. Then we have our props, and that will actually use the house material. And then we have the sand, which will also use the house material. And the windows will use this double-sided windows material. So now we imported this into Unity with the shader, and it looks a lot better than it did before. To make it look even better, we can activate a post-processing filter that I created for this game that makes the colors come out a little bit and makes it a little bit closer to Townscaper. You can change the values and add more filters as you want. Everything will be provided to you. Another cool part is that as we imported this into Unity, we can really create any type of game we want to. So if we add a mesh collider to our house and props and windows, then we can bring in a character controller and just press play, and we can walk around in our own created world. And it's really nice to see how your creation looks from a total different direction than what you have in the regular Townscaper. So it's actually very cool, and you can create a first-person shooter out of this. You can create any type of game you want to, really. So it's the possibilities are really endless, and it makes it possible to use Townscaper as a generating tool to create really cool towns that you can then make your own game with and in. Okay. So the shaders are built in shadergraph, as I needed to learn a little bit better how to use shadergraph and get better at it. If you look at in the shaders folder, we will also find one called outline from pigs, and that's the demo project that Unity has created that has a quite nice outline that I've added to this project. Then we have the different shadergraph files that makes up the different shaders that are used in this scene. And we have a couple of subgraphs to clean things up a little bit. But if we look at the houses especially, in shadergraph, it looks like this. We're not going to go into all of the details, but we're going to look at it from a high level perspective. So it has a couple of subgraphs that is used to get different kinds of information. The first one is to create this special tile UVs, that is the pixel based UVs instead. And then we have this special even odd function that gives the different gaps between the tiles that creates this special style. And we take those outputs and we feed it into a tile lookup that opens up the town color texture map, and it brings out the different tiles that should be used, or the colors of that specific pixel, and also the alpha value. Now we have another subgraph called Townscaper palette material lookup that checks what type of material is this and what type of color should be applied. Then we blend this information together with the alpha, which is a 1 minus operation on top of it. So the alpha of the Townscaper town color texture contains information how the colors should be blended together. After we are using this blend node with the mode overwrite, we get the color out of it. And then we can use our outline shader and we multiply them together and we put them as our base color. So if we dig into the palette subgraph, then we can see that it looks like this. It brings in the UVs and it takes the fraction part of the UVs and it first looks at the material. So it samples the materials texture and look, okay, what do we get out of it? And it looks for a specific color. And what we want to do is figure out what parts are the roofs in the models, because they are using a special color. So the roof check is performed, and a roof has a 100% green color and 100% blue color. Now for some reasons I have some problems with this, so I've devised a method that checks if it's greater than 0.1 in the green section, and that brings all of the roofs in the correct color. So if we are doing this, then we are checking, okay, is it greater than this? And we will return true. And if it's true, then we will use a special defined roof color that we are setting in the texture. If not, it will actually use this information from the palette texture. And what we do is we take out the first node of the UV, we floor it, so we remove all the fractions and just look at the integer part of it. And then we divide it by 16 because it's size 16, so we get our different indexes in it. And then we combine it into our own sort of custom UV, which is based on a value of 1 in the V direction and this special value in the U direction. And then we perform a lookup, and that gives us a color, which will be used if we are not detecting a roof. And then we bring it out into our house node or house shader graph and continue from there. Then we can look at our Townscaper convert UV tiles. This creates it into the sort of the pixel space instead of having a regular UVs. So we take our UVs and we take the fraction of it, so we only look at the decimal part. Then we are multiplying it with 128 to get it into the same space as the texture is, which is it's based on the size of 128. Then we offset the pixel, and we should offset it by half, but for some reason it's causing some problems with the lineup. So I'm adding 0.6. Don't ask me why, but it works. And once we have done this, then we get these special UVs, and we can use them in our even odd function. I won't even go into this, but it checks if a sort of the pixel is even or odd, and does special operations on them. So we're adding a gap if they are odd, which creates this special type of look where you're getting a much more crisp lines when you're rendering it, basically. And then we are feeding this into our Townscaper tile lookup, which takes the special UVs, and it does a check to see if it's this even or odd, if it should add a gap or not in it. And after that, it will bring back the UVs into the regular UV space of 0 to 1, and it does that by dividing it by 128, and then we sample the texture, bring out the colors, and bring out the alpha. And that is what I'm going to cover in how these sort of shader graphs are built up. I will make some comments on the other shaders as well. The plants is using a similar method as the houses, but it's using a slight animation, and the animation is actually causing some problems with the outline shader. So if you're using animations or having the trees move a little bit, then the outlines are going to be slightly off. The same for the birds, they are moving around a little bit and the outline is not correctly programmed for this, so they are sort of not correct 100%, but it looks alright from a distance, but if you come up close to a bird, it looks wrong. Now, one final part is the doors and windows, and they are using a double-sided texture or a material. So we can see in the fragment shader settings that it's two-sided. And the reason for this is if we look at the windows, so let's pick a house and a window, and we'll zoom into it. The windows are very special in Townscaper because they're not like their other textures, other models, not textures. These are built in a special ways that is that they have their faces inside out, and that's why we're rendering them with a double-sided material. If we look at bringing the house material, the regular one, we can see that it looks like this. So it's something that is very special for bringing out the houses. We can see that we can actually see the windows, but we see them sort of in the wrong way. And the reason is that they are rendered inside out. So if I look at behind, I can see that I still see something. And what is done in Townscaper is a very fancy and nifty way of creating these holes. And it's using a stencil buffer that creates the hole, and it makes it appear that there is a hole in the actual mesh. So by using this technique and rendering the windows in the correct order, then you can actually also get the correct windows. But I haven't figured that out, so until I do, I'm using the double-sided to cover up this issue. And it still looks okay. It looks a little bit weird, but a lot of people have this issue with the Townscaper, and you can see it on a lot of examples on the internet if you Google for it. But as I said before, hopefully I will find a way to solve this in Unity. And I really hope that you found this useful and that you can create something of your own, a game of your own in the Townscaper universe, if you call it that. And I mean, don't forget to give this video a thumbs up if you liked it, and please feel free to hit the subscribe button if you want to get a notification when more videos are out. All the shaders and all of the projects is available. Just look in the description for a link, and you can copy them and use them in whatever way you want to. So that's it for me today. I hope you have an excellent day.